Tens of tons is the starting weight for the specialized mobile platforms capable of traversing the frozen landscapes of Siberia and the impassable terrain of the Arctic. Why did the Russian military design vehicles of such colossal proportions that they appear to defy the fundamental laws of physics? Standard transportation remains completely ineffective in these extreme latitudes, necessitating the creation of mechanical giants that move across deep snow and permafrost as if they were light reconnaissance units. Engineering at its most extreme is the only solution for survival in these remote zones. One can notice how massive multi-axle chassis distribute their immense weight across wide, low-pressure tires to prevent the machines from sinking into the soft tundra. It only looks obvious to build a large truck, but in reality, maintaining mobility while carrying dozens of tons of cargo requires a complete departure from traditional automotive design. But this is just the beginning. The equipment gradually evolves from simple transport to specialized strategic carriers. It is visible how hydraulic suspension systems compensate for uneven ground, keeping the heavy steel frames perfectly level during movement. Everything only gets more complicated when the temperature drops below -50 degrees. Because these vehicles must operate where no other machine can survive, engineers utilized unique cold-resistant alloys and independent heating circuits for every critical component. The process is only gaining momentum as these platforms reach their deployment zones. The camera glides along the elongated hulls, revealing the sheer scale of the power plants required to move such mass. The final engineering monstrosity on this list represents the absolute limit of Russian heavy vehicle development. Metal lays in an even reinforced layer across the reinforced structures of these giants. The transition to the next level of mechanical capability defines this entire class of machinery. From pure steel and raw power, the transformation of these platforms into mobile fortresses is now complete. The journey through these massive military creations concludes here as the vehicles reach their final operational capacity. Thus, the hardware reaches the standard ready for the further stage of service in the most hostile environments on Earth. 240 horsepower was the output delivered by the engine of the KrAZ 255, a machine engineered during the most tense decades of the Cold War. Why did the Soviet military leadership prioritize the development of such a massive logistical platform? It would seem that standard transport vehicles could handle the demands of the front lines, but without a specialized heavy-duty chassis, the Army would lose all mobility in hostile terrain where paved roads were non-existent. One of the toughest machines ever built was born from this necessity, possessing the raw strength of a tank combined with the endurance of an industrial tractor. It was designed to maintain forward momentum regardless of the environmental obstacles. At first glance, the vehicle looks like a simple logistical tool, but in reality, it is a complex piece of engineering designed for survival. The heart of this mechanical giant was a 14.9-liter V8 diesel engine. This power plant generated enormous torque, which was ideal for towing heavy howitzers, massive mobile bridges, and oversized military trailers over vast distances. One can notice how the engine maintains its performance even under maximum load without any loss of efficiency. But this is just the beginning. With 8 cylinders and a direct injection system, the vehicle could operate consistently in conditions of extreme cold. The 5-speed manual transmission was specifically reinforced to handle the stresses of moving heavy loads over broken ground. The process is only gaining momentum as the power is distributed through a permanent 6x6 all-wheel drive system. Heavy-duty leaf spring suspension provided the chassis with unmatched durability over uneven surfaces. It is visible how the oversized tires provide a wide footprint, and these could be manually deflated to increase traction when navigating deep mud, loose sand, or compacted snow. The camera glides along the striking exterior, highlighting a tall and wide profile with a protruding front end. Everything only gets more complicated when considering its specialized roles. Its physical appearance resembled a cross between a dedicated military tractor and a heavy armored hauler designed to overcome any physical barrier. The deep growl of the V8 engine could be heard from a significant distance, signaling the approach of a serious industrial force. Beyond its primary logistics role, the structure was frequently adapted into mobile radar platforms and remote communication centers. It does not end at this stage. the chassis could easily support these heavy modifications without losing its center of gravity or overall stability. It was deployed across the entire Soviet Union, from the frozen reaches of the Arctic to the dense Ukrainian forests. It transported infantry troops, light tanks, and essential military engineering gear, often carrying the heavy components required for pontoon bridges and power generators. Decades after its initial production, many units still remain in active service within rural regions of Russia and Ukraine. The equipment gradually transitioned from military use to civilian sectors, specifically in forestry and specialized off-road transport. It only looks obvious that such a machine would eventually become a legend. One restored unit was even transformed into a military-style food truck for a historical reenactment event. This specific vehicle ended up drawing more attention from the public than the actual tanks on display. The KrAZ 255 concludes its journey as a symbol of extreme engineering, moving from the battlefield to the forest. 525 horsepower is the output generated by the massive 38.8-liter 12-cylinder diesel engine at the heart of this heavy hauler. Why was such a monumental power plant necessary for a single vehicle? At first glance, the sheer scale of the engine might seem excessive, but in reality, it was designed to carry the primary weight of the Soviet nuclear deterrent across thousands of kilometers of unpredictable terrain. This mission required a machine capable of hauling strategic equipment, including missile platforms, main battle tanks, and heavy aircraft weighing more than 50 tons with absolute mechanical ease. Development of the vehicle concluded in the late 1950s, with official production beginning in 1959. It does not end at this stage. Engineers equipped the machine with a 4-speed automatic transmission specifically engineered to withstand prolonged high-load missions. One can notice how the torque is distributed through a permanent 8x8 all-wheel drive system, ensuring that power reaches every tire simultaneously. This mechanical configuration allows the 21-ton tractor to traverse deep mud, thick snow, and loose sand without a loss of momentum or balance. The process is only gaining momentum. Independent suspension on all 8 axles provides the necessary stability when the vehicle moves across cratered or uneven landscapes. It is visible how the high-profile tires and independent geometry absorb the impact of the ground while maintaining a level chassis. At over 9 meters in length, the vehicle possesses a physical presence that dominates the airfields and forward bases where it operates. Because of its proven reliability and immense towing capacity, the tractor became a staple for transporting ballistic missile systems such as the R-14 and R-17. Everything only gets more complicated when considering its logistical versatility. Beyond its role as a missile carrier, the machine was tasked with hauling T-72 main battle tanks and recovering damaged aircraft from remote landing strips. It also functioned as a primary mover for heavy components in large-scale civil engineering projects. It seems simple to classify it purely as a military asset, but in reality, its reputation for ruggedness led to wide adoption by numerous Soviet allies for their own national defense forces. Many of these units remain operational today in the civilian sector, particularly within the demanding environments of heavy construction and deep-pit mining. The equipment gradually transitions from military service to industrial utility without losing its structural integrity. Modified versions of the machine, designated as the MAZ 537, played a critical role following the Chernobyl nuclear disaster. One can notice the specialized trailers attached to these units for transporting massive lead shielding components and containers filled with radioactive waste. The vehicle performed so reliably under these extreme conditions that it frequently outperformed specialized equipment built exclusively for disaster response. The camera glides along the heavy frame, which provided the necessary foundation for mobile containment systems during the mitigation efforts. This heavy tractor remains a symbol of functional engineering that continues to operate across various sectors decades after its inception. The journey of these steel giants persists in the harshest industrial landscapes, moving from one heavy task to the next. 360 horsepower is the combined output generated by the twin power plants of the ZIL E67. Why would a vehicle require 2 separate 7-liter V8 gasoline engines to function? At first glance, this configuration seems like an engineering excess, but in reality, the dual 8-cylinder engines were essential to provide the synchronized traction and immense torque needed to overcome terrain that would immobilize any standard wheeled transport. The process of conquering the Siberian wilderness is only gaining momentum. Engineers equipped the machine with a manual transmission featuring multiple gear ratios specifically optimized for low-speed performance. One can notice how the 6x6 drive system and the significantly elevated suspension allow the chassis to navigate through snowdrifts exceeding 1.5 meters in depth. The tires, standing nearly 6 feet tall, work in conjunction with a buoyant frame that enables the vehicle to partially float across unstable swamps and thawing frozen ground. It is visible how the rounded exterior lines and the centered cabin give the machine an appearance originating from a clandestine laboratory. The dimensions are imposing, with a total length of approximately 7 meters and a height of 3 meters. Small reinforced windows and a stark white paint scheme emphasize a futuristic aesthetic designed for the brutal conditions of the Arctic and Siberia. Everything only gets more complicated as the mission profile expands. Because the primary objective was the transport of heavy equipment, the vehicle served as the backbone for constructing remote bases, erecting communication towers, and supporting isolated scientific expeditions. It does not end at this stage. There exists a technical detail involving the Soviet lunar exploration program, where this specific design was briefly evaluated for extraterrestrial use. Ultimately, the complexity of its internal systems and the difficulty of manufacturing such a specialized platform prevented it from entering mass production. The KrAZ 742-8 project remains a testament to extreme engineering. Thus, the history of this unique transport concludes as a relic of specialized Arctic logistics. 650 horsepower. This was the specific output required by the Russian military in the 1990s to replace its depleting fleet of Soviet-era heavy transport platforms. Why did the transition to a new generation of tactical vehicles become an absolute necessity during this period? The aging infrastructure could no longer support the increasing weight of modern ballistic hardware, demanding a massive machine capable of hauling rocket launchers and main battle tanks with absolute stability. One can notice how the sheer scale of the resulting vehicle dominates the landscape, providing a foundation for the most heavy-duty tactical systems in the arsenal. 12 cylinders arranged in a V formation define the heart of this mechanical giant. The diesel engine displaces 46.2 liters, generating enough torque to move loads exceeding 70 tons across steep inclines or fractured soil. It is visible how the 8-speed automatic transmission operates with integrated hydraulic support to ensure fluid gear transitions even when the drivetrain is under maximum stress. But this is just the beginning. The 8x8 drivetrain configuration works in tandem with an independent coil spring suspension and specialized stabilizer bars. It seems simple to maintain balance on flat ground, but in reality, these components must counteract the shifting center of gravity during abrupt changes in terrain. The camera glides along the massive wheel arches where tires are connected to a centralized pressure control system, allowing the driver to adjust the contact patch without leaving the protected cabin. 11 meters of total length and a widened structural frame give the transporter the distinct silhouette of a road-going locomotive. The equipment gradually gains momentum as the deep metallic vibration of the engine echoes across open fields, signaling a state of total mechanical dominance. It does not end at this stage. The primary role of this platform involves the relocation of the BM-30 Smerch heavy rocket systems and the transport of armored tanks between isolated military installations. One can observe the chassis supporting heavy construction materials used by engineers to assemble bridges or tactical runways under strict time constraints. The process is only gaining momentum as the vehicle moves toward the front lines. 4 crew members occupy the high-mounted cab, which is outfitted with dedicated navigation arrays and specialized communication hardware. Light armor plating is integrated into the skin of the vehicle to provide a baseline of protection against shrapnel and small-caliber ballistic fire in active zones. Everything only gets more complicated when these machines move beyond their original borders. Export variants of the platform reached nations including Syria, Iran, and Algeria, where engineers implemented modifications to survive extreme desert heat and abrasive sand. It only looks obvious that such a machine would eventually fail, but in reality, these units maintain high operational readiness due to an exceptionally low rate of mechanical breakdown. The heavy transporters continue their service today, moving through the dust as a testament to durable industrial engineering. 525 horsepower was the output required to move the next generation of mobile missile platforms during the 1970s. Why did the demand for such massive machines increase so dramatically during this decade? The global strategic landscape shifted toward high mobility, necessitating a vehicle that was significantly larger, more durable, and capable of transporting heavier payloads through the most unforgiving environments on the planet. This necessity birthed a machine designed to operate where conventional transport would fail. One can notice the deliberate heavy movement of this mechanical titan, which functioned like a rolling wall of steel. A 38.8-liter V12 diesel engine served as the heart of the propulsion system. This massive power plant generated enough force to haul up to 65 tons of weight without any measurable loss in operational performance. Because the 12 cylinders delivered a constant and unwavering torque, the vehicle remained perfectly suited for traversing uneven and unpredictable terrain. At first glance, the mechanical complexity seems overwhelming, but in reality, every component served the singular goal of stability. A 4-speed automatic transmission worked in tandem with the engine to ensure that power distribution remained smooth across all axles. It gets more complex further on. 8x8 all-wheel drive provided the primary traction for the chassis. The suspension system was built with a robust combination of traditional leaf springs and specialized hydraulic shock absorbers to dampen the vibrations of off-road travel. The equipment gradually adapts to the surface beneath it through a central tire pressure regulation system. Engineers designed the machine so that the pressure in each wheel could be individually adjusted from the cabin. This granted the crew extraordinary control when navigating through deep swamps, shifting sands, or frozen Siberian ground. It is visible how the tires expand or contract to increase the contact patch with the soil. The process of adaptation is only gaining momentum as the vehicle moves deeper into the wilderness. 13 meters of length and 3.3 meters of height define the sheer physical presence of the machine. The extended chassis was paired with a reinforced cabin designed to accommodate a crew of 4 members. Within this armored shell, systems for internal climate control, long-range communications, and satellite navigation were integrated to ensure mission success in isolation. It only looks obvious that such a platform would carry missiles, but in reality, the frame was a versatile tool for various strategic needs. Heavy and continuous engine noise signaled the approach of the vehicle during its many deployments. It served as the primary mobile base for Scud-B missile launchers and was frequently adapted to transport light tanks or heavy radar units. Mobile command centers were also housed upon this reinforced frame, making it one of the most frequently utilized assets for long-range strategic operations. Everything only gets more complicated when considering the logistical tail required to keep these giants moving. 65 tons of steel and equipment continue to traverse the most remote regions of Russia today. These machines remain in active service within the vast expanses of Siberia, where they provide essential logistical support to advanced military outposts. The camera glides along the massive tires as they crush through thick snow and mud, proving that the original engineering remains effective decades later. Transition to the next level of durability is maintained through constant maintenance of the V12 engines. The deep hum of the diesel propulsion eventually fades into the distance as the platform reaches its destination. The vehicle concludes its heavy transit, successfully delivering its payload to the edge of the inhabited world. 400 kilometers is the maximum range this mobile tactical system could reach within minutes to neutralize high-value strategic targets. Why was such a compact platform considered more dangerous than its larger predecessors? A single missile launcher could fire its payload and change its position almost instantly, effectively vanishing before a counterattack could be launched. The project emerged in the 1980s as a response to the intensifying pressure of the Cold War, focusing on the creation of a weapon that combined rapid deployment with surgical precision. This system was capable of carrying both conventional and nuclear warheads across various theaters of operation. But this is just the beginning. Engineers selected a reinforced chassis to support the weight and stress of the 7-meter missile. Powering this massive frame was a 12-cylinder V12 diesel engine generating 650 horsepower. One can notice how the compact frame of the vehicle maintains a high power-to-weight ratio, which is essential for transporting such a lethal payload. It utilized an automatic transmission to ensure the driver could focus on navigation during high-stress deployments. The process of maneuvering through dense forests or across deep trenches was facilitated by a full-time 6x6 all-wheel drive system. It is visible how the independent suspension on all three axles allows the wheels to adjust to unstable terrain while keeping the missile platform perfectly stable. Despite the heavy weight of the hardware, the handling of the vehicle remained surprisingly agile, allowing for rapid repositioning in rugged environments. Everything only gets more complicated when considering the stealth requirements of the era. A low, squared-off silhouette and a low-profile cap were chosen specifically to minimize the visual and radar signature of the unit. At first glance, it looks like a standard transport vehicle, but in reality, this design was ideal for quick-strike operations and concealment from high-altitude surveillance aircraft and satellites. The camouflage paint and small physical dimensions compared to larger strategic launchers made it nearly impossible for enemy intelligence to track its movement in real time. The real advantage lay in its ability to fire and relocate with minimal delay. It does not end at this stage. Throughout the final years of the Cold War, this system was recognized as one of the most significant tactical threats on the European continent. Its operational life officially ended under the terms of arms reduction agreements signed between the United States and the Soviet Union. However, the technology did not simply disappear after its formal deactivation. What remained hidden from the public was that several units were retained for secret military testing well into the late 1990s. These active platforms functioned as the primary foundation for the engineering of next-generation mobile launch systems. While a few surviving examples are currently preserved in military museums, the vast majority of the fleet was systematically dismantled to ensure that the technology could not be reused without authorization. The metal from these launchers was recycled, marking the quiet conclusion of a once-feared weapons program. 1,500 horsepower is the output generated by the state-of-the-art 12-cylinder diesel engine at the heart of the KrAZ 7550. Why did the modern Russian military doctrine necessitate the development of such a complex new platform? The previous generation of transporters lacked the onboard electronics and modular flexibility required for contemporary strategic missions. By integrating a massive V12 power plant and advanced computing, engineers created a machine capable of carrying significantly greater cargo loads than the older models it was designed to replace. This technological leap is not merely about raw power. One can notice how the 8-speed automatic transmission operates in tandem with an intelligent electronic management system. It is visible how the software optimizes torque distribution across the gears, which effectively reduces fuel consumption during long-distance deployments while the vehicle is under full load. The process is only gaining momentum as the mechanical systems interface with the digital core. 16 wheels across a 16x16 drivetrain ensure that every single point of contact with the ground is a driven axis. But in reality, maintaining such a massive footprint requires more than just standard axles. A hydropneumatic suspension system equipped with electronic control serves as the foundation for the entire chassis. Even when traversing uneven or unstable terrain, the equipment gradually performs automatic leveling adjustments to maintain the absolute stability of the launch platform. Over 20 meters of length and nearly 4 meters of height define the physical presence of this rolling missile base. Modular design principles allow for the rapid interchange of critical components depending on the mission profile. The camera glides along the frame where strategic missile launchers, additional armor plating, or specialized surveillance equipment can be swapped with precision. The cabin structure itself is reinforced and outfitted with internal climate control, light armor, and fully automated navigation systems to protect the crew. Everything only gets more complicated as these systems are synchronized for combat readiness. Because the RS-24 Yars intercontinental missile requires extreme stability during transport, the KrAZ 7550 serves as its primary mobile carrier. It only looks obvious to move such a heavy weapon, but the vehicle must do so with unexpected stealth. Onboard global positioning systems and high-precision sensors allow the platform to achieve exact positioning for launch operations with a minimal acoustic signature. The project is still evolving as new upgrades are integrated into the existing architecture. This platform is expected to become the standard component for strategic operations, systematically phasing out the aging fleet of military transporters. The transition moves to the next phase as more units enter active service. 710 horsepower. This is the massive output generated by the V12 diesel engine hidden within the reinforced hull of the DT-30PM. Why was such an extreme power plant necessary for a single transport unit? It would seem that standard heavy trucks could handle industrial loads, but in the most hostile environments on the planet, wheels become a liability rather than an asset. This articulated tracked vehicle functions as a specialized militarized supertractor, specifically engineered to navigate the Arctic, where traditional logistics completely fail. The power from the massive engine is distributed with mechanical precision between two distinct articulated modules that form the backbone of the machine. One can notice how the front section houses the command cab and the primary propulsion systems, while the rear unit is dedicated to hauling massive payloads of up to 30 tons. The automatic transmission is equipped with multiple gear ranges, allowing the operator to adapt traction instantaneously as the terrain transitions from frozen earth to deep snow. It is visible how the continuous tracks replace wheels entirely, spreading the weight of the machine to ensure it does not sink into soft sand or slushy mud. But this is just the beginning. The suspension system is reinforced with heavy-duty torsion bars and hydraulic elements that ceaselessly adjust to keep the tracks in contact with the ground. It looks superficially simple to drive over a frozen obstacle, but in reality, these hydraulics prevent the chassis from snapping under the strain of extremely uneven terrain. 16 meters is the approximate total length of this industrial giant, which takes on the appearance of an articulated train as it maneuvers through the tundra. The flexible structure located between the two modules allows the vehicle to snake around obstacles that would stop a rigid frame in its tracks. One can observe the futuristic silhouette of the cab, characterized by small, high-pressure windows and a body reinforced against the crushing force of the environment. The process of movement is only gaining momentum as the white or camel-colored camouflage allows the machine to blend into the desolation of the Arctic Circle. Everything only gets more complicated when the mission parameters are considered. The Russian military forces deploy these units for the most remote Arctic Circle missions, utilizing them to transport heavy weaponry, sensitive electronics, and vital supplies to isolated research stations. The equipment gradually moves across the landscape to install communication towers in regions that are considered nearly inaccessible by any other form of transport. At first glance, the machine is just a heavy hauler, but in reality, its survival capabilities are its most impressive technical feat. The DT-30PM remains fully operational in temperatures plummeting below -50 degrees Celsius. It maintains absolute stability even when crossing the treacherous shifting surfaces of frozen lakes or unstable permafrost. Transition to the next level of engineering is required to keep the fluids from freezing and the metal from becoming brittle at such extremes. The heavy tracks continue to rotate, ensuring the cargo reaches its destination regardless of the thermal conditions. The journey through the ice concludes this phase, opening the road to long-term survival in the deep cold. 1,250 horsepower is the mechanical output generated by the specialized gas turbine engine at the heart of the MAZ 7907. Why was such a complex propulsion system chosen for a land-based transport vehicle in the 1980s? Conventional diesel engines of that era could not provide the necessary power-to-weight ratio required for a machine of this magnitude. By pairing the turbine with individual electric motors mounted directly on each of the 24 wheels, Soviet engineers created an advanced diesel-electric drive that eliminated the need for fragile mechanical drive shafts across its 12 axles. The project remained shrouded in strict classification for decades. Engineers designed this platform specifically to transport massive intercontinental ballistic missiles in a secure and mobile fashion across varied terrain. One can notice how the body stretches like a land-bound freight train, reaching a total length of 28.8 meters and a height exceeding 4 meters. It looked nothing like a traditional truck due to its long, narrow command cab and dark, non-reflective paint scheme. Everything only gets more complicated when considering the internal weight management systems. At first glance, moving a mass of over 150 tons seems impossible without destabilizing the chassis. But in reality, the vehicle utilized a fully electronic active suspension. The equipment gradually adjusts the height and tilt of the frame in real time with millimeter precision. This automatic load-leveling system was unheard of in the 1980s, ensuring the delicate nuclear warheads remained stable even during complex maneuvers. The process is only gaining momentum as the vehicle transitions from stationary positioning to active transport. Each wheel functioned as its own independent power source. Unlike most heavy military vehicles that produce a rhythmic diesel thrum, the combination of the gas turbine and electric motors generated a strange, high-pitched metallic hum. This acoustic signature was a byproduct of the high-speed rotation within the turbine housing. It does not end at this stage, as the vehicle was subjected to rigorous testing at secret military bases. One can notice the dust slowly settling behind the 12 axles as the massive frame moves across the proving grounds. The system was designed to operate under deep cover, moving intercontinental nuclear warheads far from the surveillance paths of Western satellites. Although the machine never entered mass production, it impressed observers with its unprecedented performance metrics during trials. It is visible how the sheer scale of the engineering dominates the landscape, representing the pinnacle of Soviet military transport development. But this is just the beginning of its legacy. Today, only a single prototype remains under watch within a secure military facility. Many engineers still consider this machine the most complex and ambitious land-based military vehicle ever constructed for non-combat logistics. The metal remains preserved in its original form, serving as a silent testament to a period of radical technological experimentation. The material reaches the end of its operational history, transitioning into a calm stage of historical preservation. Tens of tons of specialized steel and reinforced rubber form the foundation of machines that redefine the limits of mechanical endurance. Why did engineers design these platforms with such an extreme margin of safety? At first glance, they appear to be standard heavy transport vehicles, but in reality, their chassis are engineered to maintain structural integrity across frozen tundra, deep mud, and zones of high radiation. This level of durability ensures that the mobile platforms can execute missions involving the transport of strategic nuclear assets in any environmental condition. The process of technological evolution is only gaining momentum. These units have transitioned through decades of strategic deployment, appearing in remote nuclear testing grounds and high-stakes polar explorations. One can notice how the reinforced frames and multi-axle drive systems allow the equipment to gradually navigate terrain that would immobilize conventional transport. Everything only gets more complicated when considering the weight distribution required to carry massive ballistic missiles without compromising the speed of the deployment cycle. It is visible how the heavy-duty suspension systems compress under the immense weight of the metal superstructures. Decades of specialized engineering strategy and technical ambition are concentrated within these mobile units. The equipment gradually maneuvers through the most hostile landscapes on the planet, serving as a physical manifestation of industrial power. From the early prototypes to the modern multi-wheeled giants, the design philosophy remains focused on absolute reliability under extreme loads. The machines continue their service as a testament to the specialized branch of heavy transport development. Every component, from the high-torque engines to the armored cabins, represents a specific stage in the advancement of high-mobility logistics. Thus, the heavy transport platforms reach the standard required for the most demanding technical operations, and the material remains ready for the next phase of its functional life.